Hi, this is problem number 6 on coplanar non-concurrent system of forces. The question is to find magnitude, direction and point of application of the resultant force uh, and to locate the position with respect to the point O. Okay. Now initially we will find magnitude and direction of the resultant force. Point of application means it is nothing but position of the resultant force. Okay, it is asked to find position with respect to the point O. Okay, so initially we will identify all the inclined forces and write the components for inclined forces. Here we have 100 Newton and 300 Newton forces as inclined forces. For that we have to write the components first. To write the components we need the angles. The angles are not given, we have to find it. Okay, we will find the angles now. Let me call this as angle theta 1, this as angle theta 2. Okay, I will call these points as point A, point B and point C. Okay, now to find angle theta 1, you take right angle triangle BAO. Okay, right angle triangle BAO, apply tan function, means theta 1 is equal to tan inverse of opposite by adjacent. Opposite is 2 meter, adjacent is 4 meter, 2 by 4. By this we will get the angle as 26.56 degrees. Similarly, theta 2, to find theta 2 you take the right angle triangle COD. Theta, if you apply tan function, no, theta 2 is equal to tan inverse of opposite by adjacent. Opposite is 2 meter, adjacent is 2 meter, 2 by 2. You will get the angle as 45 degree. Okay, you will get the angle as 45 degree. Let me write these angles here. Theta 2 is equal to 45 degree. Theta 1 is equal to 26.56 degree. Okay, using these angles we will write the components. Okay, here we will have the same angle. Okay, we will have the same horizontal angle here, that is 26.56 45. Therefore for 300 Newton force, horizontal component is 300 cos 26.56, vertical component is 300 sin 26.56. For 100 Newton force, horizontal component is 100 cos 45, vertical component is 100 sin 45. Now we will find sigma fx. Therefore sigma fx is equal to sum of forces in each direction. So we will start adding from 250 Newton force. 250 Newton force is acting in right direction, plus sign, plus 250, and 100 cos 45 acting in left direction, minus sign, minus 100 cos 45, and here we have 300 cos 26.56 acting in right direction, plus sign, through 300 cos 26.56. Cos 26.56, and we have 100 Newton force acting in left direction, minus 100. So I think we have covered all the horizontal forces. For this, answer is 347.6 Newton. 6 Newton. Now we will find sigma Fi, sum of forces in y direction. So we have 100 sin 45 acting in upward direction, sin is plus, 100 sine 45, and we have 100 Newton force here acting in upward direction, plus 100, then we have 300 sine 26.56 acting in upward direction, plus 300 sine 26.56, then we have 200 Newton force acting in downward direction, minus 200. Answer is 104.85 Newton. Now we can find magnitude of the resultant force. We know the formula R is equal to root of sigma fx square plus sigma fy square, which is equal to root of 347.6 square plus 104.85 square. The answer for resultant force is 363 Newton. 363 Newton. Okay. And direction of the resultant force, we know the formula theta is equal to tan inverse of sigma fy by sigma fx, which is equal to tan inverse of 104.85 divided by 347.6. The answer is angle theta is equal to 16.78 degrees. To this, magnitude and direction of the resultant force is over. Now we will find position with respect to point O. Okay. To find position with respect to point O, we need moment about O. Sum of moments of all the forces about point O. Okay, we will find the moment now. We will find moment of 250 Newton force about point O. 250 into what is the perpendicular distance of point O from the line of action. So this is the line of action of 250 Newton force. Okay, line of action 250 Newton force. So this is the line of action. We have the point E here. So distance of this point O from the line of action is 1.5 meter into 1.5 meter. And about point O, if you apply a 250 Newton force here, the plate will rotate in clockwise direction about point O. Sign is plus. Then you take 100 cos 45 force, 100 cos 45. Okay, and perpendicular distance will be, so this is the line of action of 100 cos 45. We have the point O here. Distance of point O from the line of action is how much? It is 2 meter into 2 meter into 2 meter. About point O, this force, if you apply leftward force at this corner, see, the plate will rotate in anti-clockwise direction. Sign is minus. Now you take vertical component 100 sin 45, 100 sin 45 into, if you draw the line of action of 400 sin 45 force now, so this is the line of action. Point O lies in the line of action of the 100 sin 45 force. So there is no distance of point O from the line of action. So you can directly write into 0. Put plus or minus, it will be 0 only. Now we will go to 100 Newton force here. 100 into, what is the perpendicular distance? So first you draw the line of action. So this is the line of action of 100 Newton force, right? So this is the line of action. We have the point O here. Distance of point O from the line of action is how much? It is 3.6 meter. 3.6 meter. And about point O, if you apply upward force at this edge, the plate will rotate in anti-clockwise direction. Sign is minus. Now you take this horizontal component, 300 cos 26.56 force, 300 cos 26.56 into, what is the perpendicular distance? Before that we will draw line of action. So this is the line of action of 300 cos 26.56 force. So this is the line of action. Okay, so this is the line of action. We have the point O here. Distance of point O from line of action is how much? 2 meter into 2 2, and about point 4 if you apply a rightward force at this corner B, okay, the plate will rotate in clockwise direction, sign is plus. Now you take vertical component 300 sin 26.56 force into perpendicular distance. Before that, draw the line of action. So this is the line of action of 300 sin 26.56 force. So this is the line of action. This is the line of action. We have the point O here. Distance of point O from the line of action is 4 meter into 4 into 4, and about point O, if you apply upward force of 300 sin 26.56 force at point B, the plate will rotate in anti-clockwise direction. Sign is minus. Then you take moment of this 100 Newton force, 100 into what is the perpendicular distance? For that, draw the line of action of force. So this is the line of action of force. This is the line of action. This is the line of action. You have the point O here. Distance of point O from the line of action is 1 meter into 1 meter into 1 meter, and about point O, if you apply leftward force at this edge, 100 Newton magnitude, and the plate will rotate in anti-clockwise direction. Sign is minus. Sign is minus. So finally we have left with this 200 Newton force. 200 into line of action of the 200 Newton force is, this is the line of action. This is the line of action. We have the point O here. Distance of point O from the line of action is 2 meter into 2 into 2, and about point O, if we apply downward force at this edge, the plate will rotate at clockwise direction. So sign is plus. Finally, there is a moment given at this particular point here, and we can just observe the arrow mark. It is a clockwise moment. Okay, the direction of rotation is clockwise. Okay, it is a clockwise moment. For clockwise moment, sign is plus 200. No need to multiply the distance here. It is directly the moment. The distance is already multiplied here. Okay, it is directly the moment. Just you need to add that value plus 200. If it is anti-clockwise, you have to take negative sign. That's it. Okay, so therefore sigma m naught, answer is mo, answer is 373.7 Newton meter. Okay, this is the moment about O. Now we can find x-intercept. You know the formula. X-intercept is equal to sigma m naught by sigma fi. Sigma m naught is 373.7. Sigma fi is 104.85. The answer is 3.56 meter, and y-intercept is equal to sigma m naught divided by sigma fx, which is equal to 373.7 divided by, sigma fx is 347.6. 347.6. Answer is 373.7 divided by 347.6. 1.07 meter, and d is equal to sigma m naught divided by r, 373.7 divided by resultant force is 363. Therefore answer is 373.7 divided by 363, 1.02 meter. Okay, so to this determination of the position of the resultant force with respect to the point O is also over. Okay, this completes the problem. Thank you.